Welcome back to part 2 of our probability series. In part 1, we nailed the basics of single events. Now, we're leveling up. What happens when we combine events, like rolling 2 dice or choosing from different categories? That's our focus today. Let's start with a classic exam-style context. Imagine a survey of 40 Year 10 students about sports. We can find probabilities directly from a two-way table. For example, the probability a randomly chosen student plays rugby. Look at the plays rugby column. That's 12 plus 5 equals 17 students. So, the probability of rugby is 17 out of 40. Simple, right? Now, a Venn diagram shows the same relationships visually. The key rule to remember, and means the intersection, the overlap. So, the probability of football and rugby is 12 out of 40. But what if we want to list all possible outcomes for two events? We construct a sample space. For 2 dice, there are 6 times 6 equals 36 equally likely outcomes. This is crucial for finding probabilities, like the probability the total score is 7. Count the pairs that sum to 7. There are 6. So, the probability is 6 out of 36, which simplifies to 1/6. Now, a super important concept. Independent events. Independent events mean the outcome of one event does not affect the probability of the other. Flipping a coin and rolling a die are independent. Getting heads doesn't change the chance of rolling a 4. The rule is beautiful in its simplicity. For independent events, you just multiply the individual probabilities. So, the probability of heads and a 4 is 1/2 times 1/6, which equals 1/12. The best tool for handling multiple independent events? A probability tree diagram. Let's do an example. A spinner has a 1/3 chance of landing on red. I spin it twice. Follow the branches. The probability of red on the first spin and red on the second is 1/3 times 1/3, which equals 1/9. We multiply along the branches. To find the probability of getting exactly one red, we look at the paths for red then not red and not red then red. Calculate each. 1/3 times 2/3 is 2/9, and 2/3 times 1/3 is also 2/9. Then, because these are different outcomes, we add them. 2/9 plus 2/9 equals 4/9. So, let's recap your probability toolkit for combined events. 1. Use tables and Venn diagrams to find frequencies. 2. Construct sample spaces to list all outcomes. 3. For independent events, multiply their probabilities. 4. Use tree diagrams to map out paths, multiply along the branches, and add probabilities for different outcomes. Remember, for independent events, it's all about multiplying along the branches of your tree. Master these 4 steps, and you've conquered a huge chunk of GCSE probability. Thanks for watching.